Hey everyone, how's it going? In this video, we're going to work on an example of creating a linear function based on a word problem. So the problem reads, in water, the greater the depth, the higher the pressure. For every 10 meter increase in depth, water pressure increases by about 100 kilopascals. At a depth of 40, the pressure is approximately 500 kilopascals. The first thing the problem wants us to find is what is the rate of change in this relationship. So let's take a look at the information that we're given. It says at a depth of 40, the pressure is approximately 500 kilopascals. Does this tell us anything about how the pressure is changing? Well, not really. All it tells us is that at a depth of 40, the pressure is 500. So let's take a look at the second bit of information. For every 10 meter increase in depth, water pressure increases by about 100 kilopascals. This does tell us how something changes. So in order to solve this, we're going to create a proportion. We're going to say for every 10 meters, we increase 100 kilopascals. And whenever we're looking for a rate of change, we usually look for it in terms of singular units. So here we have 10 meters, but for rate of change, we're going to try to find it for 1 meter only. So we don't know how much that is, so we're just going to call it x kilopascals right now. And we're going to solve this like we would any other proportion by cross multiplying. So what do we get? We get 100 equals 10x. So we divide both sides by 10. The 10 and the 10 cancel. Zeros cancel. We end up with x equals 10. So that means for 1 meter, we increase our pressure by 10 kilopascals. From this, we can say that our rate of change is 10 kilopascals per meter. Now, the second part of the problem says, write the equation of a linear relation representing the pressure P at a depth D under water. So, what is our dependent and independent variable? Well, in this case, our pressure depends on the depth. So, pressure is going to be dependent and depth is going to be independent. So if our pressure depends on our depth, the equation is going to be solving for P, pressure. And we're going to have to write it in terms of D. So for any linear relationship, it's always going to follow the form mx plus b. Except in this case, instead of x, we're just going to be using d. So now we have to figure out what our slope m is going to be and what our y-intercept b is going to be. Well, what is slope? Slope is just how much the line changes over a given distance, which is kind of like rate of change. So we actually already found our slope. It's 10. So we can just plug that in right here, and we can say pressure is equal to 10d plus b. Now, to find b, we have to be given a point. And if we look, we actually already are given a point. We're told at a depth of 40, the pressure is 500. So we have the point already handed to us, 40, 500. Now, there's a few ways you can solve this by plugging this in. I'll show you both of them. So 40 is our depth, 500 is our pressure. So one thing you could do is obviously just plug 40 in for depth, 500 in for pressure, and solve for B. So we can get 500 equals 10 times 40 plus B. 500 is equal to 400 plus B. And you can get B equals 100. The other way you could do it is actually using the equation y2 minus y1 is equal to mx2 minus x1. So in this case, our x1, y1 is just going to be the point 40 and 500. So I'm going to have y minus 500 is equal to our slope, which we said is 10 times x minus 40. Now, I'm going to distribute this. I'm going to get y minus 500 is equal to 10x minus 400, sorry. And now what I'm going to do is I'm just going to add 500 to both sides. And I'm going to, once again, get, I'm going to get y equals 10x plus 100. So both of these problems give us the same answer. Both of these ways give us the same answer. And this is the linear function that represents this rate of change, 10 meters, 100 kilopascals every 10 meters, and also a pressure of 500 kilopascals at a depth of 40 meters. So I hope this video helped. If you have any questions, let me know. And as always, happy studying.